Students, good evening. Today I am giving you one small clarity about on hydrocarbons. Hydrocarbons basically involved in which chemical reactions? That point I am highlighting now. Hydrocarbons. Hydrocarbons means what? Carbon and hydrogen containing compounds are hydrocarbons. You know that already hydrocarbons, alkane, alkene, alkyne and benzene. These are the hydrocarbons. These hydrocarbons involved in which chemical reactions? That is the important thing. Few students sometimes they are facing how to identify the chemical reactions, the particular compound involved in which chemical reactions. They are facing the problems in organic chemistry point of view. Now here the four molecules are present. Observe these molecules. Here this one is benzene. You know that already benzene formula C6H6. Here the 6 carbons, around that 6 hydrogens are present. Inside the benzene ring alternative pi bonds are present. This is the structure of the benzene. Here look at here. Alternative pi bonds are present. This is the structure of the benzene. Benzene structure is existing like this, alternative pi bonds. So benzene is nothing but what? Aromatic compound. So aromatic compounds involved in which chemical reactions? Not only benzene, aromatic compounds involved in which chemical reactions? That is the important thing to understand. Aromatic compounds involved in which chemical reactions? Leave this benzene. It is a hydrocarbon aromatic compound. Another molecule. Here, look at this molecule. Observe here. The central, here these are the carbons. Around the carbon, hydrogens are connected like this. This is CH3. This one is CH3. So CH3 single bond CH3. This is alkane. So alkane involved in chemical reaction. This is the ethane. You know this. Ethane, that means alkane. Alkanes are involved in which chemical reactions? Majorly involved in which chemical reactions? Leave this. Next, take this another molecule. Observe here this molecule. This is carbon, this is the carbon. Between the carbon atoms, what is present? Double bond is present. One is sigma bond, another one is pi bond. Here the two hydrogens are connected. Here the two hydrogens are connected. CH2 double bond CH2. So ethene, alkene. Alkenes are involved in which chemical reactions? Alkene molecules involved in which chemical reactions? Next, another hydrocarbon, that is alkyne. Here between the carbon atoms, what is present here? Triple bond is present. One is sigma bond, another one is pi bond. Triple bond is present. Here hydrogen, here hydrogen. CH triple bond CH, alkyne. Alkynes are involved in which chemical reactions? Okay, these hydrocarbons involved in which chemical reactions? Now look at here. Alkane molecule. In alkane, between the carbon atoms, what is present? Sigma bond is present. This sigma bond is formed by which orbitals overlapping? Actually, around the carbon, 4 bonds are present. What is the hybridization of the carbon? sp3. You know that already. So, sp3 hybrid orbital of this carbon, sp3 hybrid orbital of this carbon overlapping to each other, that is end to end overlapping. We are representing like this, end to end overlapping. End to end overlapping forms the strong overlapping. End to end overlapping gives a strong sigma bond, end to end overlapping. So this sigma bond is formed by sp3 hybrid orbital of one carbon, sp3 hybrid orbital of another carbon. Next, this is also sigma bond. This sigma bond is formed by sp3 hybridized orbital of carbon and s orbital of hydrogen. This overlapping is sp3s overlapping. sp3 hybridized orbital of carbon and s orbital of hydrogen. This overlapping is sp3s overlapping. S orbital, you know that. It is orientation along x-axis based, y-axis based and z-axis based. So strength of the bond is more strong bond. Strength of the carbon hydrogen bond is more strong bond, as well as carbon carbon sigma bond also more strong bond because of end to end overlapping. This is sp3 hybrid orbital, this is s orbital. Strength of the bond also here more. Breaking this bond, With normal reagents, not possible. Laboratory reagents at normal conditions, breaking this bond is not possible. Different conditions are required. What are the different conditions? High temperature or light, sunlight. HNU condition is needed. At sunlight condition or at high temperature condition, the bond is breaking like a homolytic cleavage. What is the meaning of the homolytic cleavage?